right, thank you for the introduction. Hello, I am Yoko Hirano working for DMG Mori. I am in charge of AM machine development. Today, I'd like to talk about DED side of AM. First of all, let's look at the AM market. 2020 metal AM market is 2 billion and 70% of this is SLM. Expected fields were changed from high value added fields like aerospace or medicals to industrial fields like automotives. The market is considered to grow highly as CAGR from 2020 to 2025 is around 30%. I know the participants are really familiar with AM, but I just want to share the industrialization index. As we expected, the powder bed fusion or selective laser melting is the most industrialized technology. And the next one is DED, directed energy deposition, the LMD, laser metal deposition. The DED is the machine has laser head and nozzle. The laser and powders are coming from the nozzle. Powders are melted by laser and solidified on the base material. And on the other hand, the SLM is maybe no need to be explained, but spread powder material over the previously joined layer ready for processing of the next layer. Now we move on to the DED market. This data came from AM Power, and we can see the strongest growing market among AM is DED. I was thinking why DED is spreading, and one idea came up to me. Let me explain to use this slide. This slide shows the target market for DED, and this was made by voice of customers. 5 years ago, 10 years ago, they were thinking to use DED for making whole large parts from scratch. However, for instance, look at the oil and gas field. They need wear-resistant surface coatings for drill bit or multi-material manufactured body. For the screw shaft of industry fields, they can use the low-price base shaft and just added the screws by DED on it. For this part, they added copper-based alloy parts on normally subtractive manufactured part, or they are repairing molds by DED. So, in summary, we can use the DED not only building up, but also coatings and multi-materials or repairings. This is the portfolio we have in the advanced technologies. We have ultrasonics and laser subtractive machines, and also we have the additive manufacturing machines. The last line is the SLM side, and we have the DED machines here. We have the additive only machine and also hybrid machine. Hybrid machine has additive manufacturing and plus cutting subtractive manufacturing. And we have the 5-axis based machine and also mill turning based machine. So I think the customer is not interested in what the AM machine itself, what AM machine DMG Mori is making, but I think the customer or users are interested in what kind of parts the machine can create and what is the quality of that. So this page shows the quality evaluation results and we confirmed the porosity 5%. That means the density is 99.95%. This slide shows the tensile strength test. We are comparing to casting, hot forging, cold forging, and we found the value of our machines are between hot forging and cold forging. Which is pretty good, isn't it? And next application test is wear-resistant coating. We did coat test by cladding of cobalt alloy on shaft-shaped base material. Setup is like this, and we can see the layer surface as built and calling finished surface here. No holes or no cracks on the finished cutting surface, no peeling of the drying fishing cuttings. The hardness was Vickers 530. And next test we were using 72. For the people need much higher hardness, we use the powder high-speed steel, which is called as HAP 72. No holes, no cracks again, and no peeling during finish cutting as well. The hardness was, I was surprised, but the Vickers 870, the hardness, and even after the heat treatment, we got the HAP 72 hardness Vickers 1000. So this is really hard material we can clad and we can deposit by our machine. And from this slide, I would like to talk about the quality. Now, AM is not the prototyping, but the production stage. So many users are worrying about the quality control. We released some quality control functions. First one here is melt pool monitoring. This monitoring is monitoring the melt pool temperature and area. And the next one is working distance monitoring. Working distance is the distance between nozzle and melt pool here. This is very important for the stable building. And this one is working area monitoring. We have to think about the workpieces, whole workpieces, not only the melt pool. So we put this monitoring system here. And we also have powder flow sensor and powder calibration system. Slightly more detail for working distance monitoring. We added one more camera here to observe the working distance between nozzle tip and melt pool. As we can, if the working distance is out of required area, the machine stops with alarm. We developed the image-based algorithm to calculate the working distance. And this page shows the working area detail. This is a contactless workpiece temperature measurement system. Whole working area can be observed. User can decide where they would like to see to use the specific process window. This slide shows the powder calibration unit. The calibrated in-sheet detector monitors powder mass flow during the cladding process and irregularities in the powder feed rate can be detected. The last one is nozzle adhesion detection. We developed the image analysis to detect the nozzle adhesion here by processing materials with unfavorable clotting behavior. The system diagram is like this. From this page, I would like to share the customer success. First one is mold repair by Toyota Bowden. This is the worn out mold, damaged mold, and 3D scanner detects where has to be repaired. And then, because this machine is a hybrid machine, so cutting and DED has. So the worn out part cut first. After this, needed part is repaired by DED and finish culling. Then we can get like brand new mold again. The customer says they could get 3 times life expectancy compared to manual repairing when operators are repairing by hand. Sometimes something happens and or the finished quality is depend on who did it. Now, customer says no reworks are needed. Second one is the success story by Virgin Orbit. They are making rockets. To make this rocket nozzle, they are using 2 technologies, SLM and DED. They are manufacturing copper rocket nozzle inside parts by SLM first, and then they coat heat-resistant material like Inconel by DED. They say they could shorten the 90% lead time. That means 10 times productivity. The left point, they are using DED for pump shaft repairing. The worn out bearing wheel along pump shaft is like this. And if this part is old and if they don't have a drawing, they can use the 3D scanner and they can get a 3D model by reverse engineering. And damaged area was removed by cutting and then deposited AM for repairing. And the as-built surface is like this. Like new part was obtained by fishing finished cuttings. And the final topic is about carbon neutral. I'd like to talk about how we can contribute to the carbon neutral society by DD or SLMs. The process integration helps production time reduction, and that helps to reduce CO2. The left one is about gear production for transmission. Conventional process work, they have to use their turnings, hoppings, chamfering, hardenings, and grindings. Our DD machine is hybrid and can integrate these processes. The right one is repairing mold, like Toyota Bowden said. They can reduce the final culling time because DD can make thinner layers than these welding processes by hand. If the repaired part is larger, the more finishing cutting time is required. That is why the processing time is reduced by using DD, and even changing over time is also reduced by integrating repair and finishing into hybrid AM process. This is the end of my presentation, and feel free to email me when something happens, something comes up to you. Thank you very much.
Awesome. Thank you for joining us here today, Yoko, and working with us to get your presentation up and running. So I've got a few questions here for you, and for others on the call, feel free to put any additional questions in the chat. Just confirming you can hear my mic a little bit better than maybe before as well?
Brilliant. Yeah, great.
Cool. So the first question I have for you is why DMG Mori, why have they chosen to develop a hybrid system?
Thank you for the question. From the industry 4.0, they are looking at the digitalization or artificial intelligence. And we think these are not the one we have to think first. The one tracking or process integration first we have to think about. Then automation is needed. Then people are not in front of the machine. Then we have to collect kinds of data instead of people. Then much data we have, and we can use this data for digitalization and AI improve the system. So we think this machine, hybrid machine, is the process integration machine, the base for technology. So we thought the hybrid system is the mass development item. Yes.
Awesome, great answer for that one. And like with the DED process that obviously you shared on today and you've just spoken about, what for your organisation is your targeted field of application? Do you have a specific target as DMG Mori?
Yes. So several years ago, they were thinking about to use AM as building up complicated parts system. Thinking about the SLM, that is true. But when it comes to talk about DED, that is something true and something sometimes maybe not. As presented, DED enables us to not only build up from scratch, but also adding some parts, coating wear resistant or heat resistant material, make multi-material parts, and so on. So we are looking at not only high value added like space industry, but also the normal industry like the die cut roll, screw shaft, or molds, and so on. Thank you.
Awesome. It sounds like you guys are targeting some broad but like areas as well. But obviously, it's nice to see how that's translated over time. So a question from myself to you is, in the year of 2022, what is a specific project or part you're designing that you're really looking forward to the challenge?
We were looking at the quality control by monitoring melt pool or the workspace area, but we would like to make the AI system for the customer. The customer wants to know the mechanical properties like tensile strength or porosities, or what kind of mechanical properties they can get, and they need the input parameter like laser power or powder feed rate. So they would like to get the good mechanical property. And how? What parameter they use? If they use, they get the good mechanical property. So we need to match this by artificial intelligence and understanding the mechanism. So we will create the software for the customer to automatically create the parameters to get the good mechanical property.
Thank you for that answer. I'm a keen finder of those mechanical properties myself. So obviously that comes into assurance and certification. And as more companies trend towards needing to use these parts, actually in application, that's becoming increasingly important. So knowing that you and your team are working on finding easier ways for your customers to get that information, obviously is going to be a well-needed information source, or access to that information more easily and readily. Well, thank you for joining us, Yoko. I haven't seen any additional questions in the chat or in the Q&A, but just a little bit of a last call out for any questions for Yoko. Please feel free to put it in the chat. Otherwise, Yoko, I'm sure you're going to join us for some networking shortly after in the industry roundtable room. So just stay online with us for a bit, Yoko.